Good day. In this lecture, we will discuss air pollutants, focusing on their type, their sources, and their effects. By the end of this lecture, you should be able to identify the different types of air pollutants and understand their impacts. Air pollutants occur naturally. Examples include wildfires producing particulate matter and carbon monoxide, lightning producing ozone and nitrogen oxides, and volcanoes releasing sulfur dioxide. Major air pollutants include ozone, carbon monoxide, nitrogen oxides, sulfur oxides, particulate matter, lead, and other toxic compounds. We will examine each in detail. Let's start with ozone. Ozone has a sharp odor and exists in both the troposphere, where it contributes to smog, and the stratosphere, where it protects against UV radiation. Ozone can be formed when nitrogen oxides and volatile organic compounds combine chemically with oxygen in the sunlight. Even at low concentrations, ozone can irritate the lungs and reduce lung function. The second one is carbon monoxide, which is considered as the silent killer because it has no color, no taste, no smell. Carbon monoxide is released when engine burn fossil fuels, such as in the automobile exhaust, in charcoal fires, propane pumping stoves. When inhaled, carbon monoxide passes into the bloodstream and interferes with the ability of the hemoglobin to carry oxygen. Carbon monoxide exposure makes people dizzy, tired, and gives headaches, but continued exposure can actually kill. The next one are your nitrogen oxides. They refer to a binary compound of nitrogen and oxygen or a mixture of such compounds. For example, we have the nitric oxide and the nitrogen dioxide. We also have N2O, which is your nitrous oxide, and your N4O, which is your nitrosyl azide. Nitrogen oxide is a reddish-brown gas that comes from the burning of fossil fuels, such as in the case of the power plants and automobiles. They have strong smell at high levels, and they are primarily visible component of your urban smog. They can also react in the atmosphere to form ozone, acid rains, or particles. Nitrogen dioxides can also combine with the moist tissues in the lungs to produce an acid. They can cause cough and shortness of breath, as well as respiratory infections. Now, nitrogen dioxide is produced from nitrogen monoxide. The common name for nitrogen monoxide is nitric oxide, and it is a colorless gas. They are formed when the nitrogen in the fuel is burned or when the nitrogen in the air reacts with the oxygen at very high temperatures, such as in the case of vehicle engines and coal-fired power plants. Sulfur oxides refer to the binary compounds of sulfur and oxygen or a mixture of such compounds. We have SO for sulfur monoxide, SO2 for sulfur dioxide, and SO3 for sulfur trioxide. It can also exist in S2O, which is your disulfur monoxide, S2O2, which is your disulfur dioxide, and lower sulfur oxides. It can also exist in the higher sulfur oxide forms such as the SO3 and SO4. Sulfur dioxide is a corrosive gas that cannot be seen or smelled at low levels but can have rotten egg smell at high levels. They mostly come from the burning of coal or petroleum in the power plants and also comes from factories that make chemicals, papers, and fuels. Like nitrogen dioxide, sulfur dioxides react in the atmosphere to form acid rain. SO2 exposure can affect people with asthma or emphysema by making it more difficult to breathe. Sulfur dioxide can also irritate the eyes, the nose, and the throat. They can harm trees and crops as well as damage buildings. Sulfur dioxide reacts in the atmosphere to form acids which fall as acid rain. These reactions damages materials such as marble, which is composing of calcium carbonates, and they react with the sulfuric acid to form calcium sulfate, water, and carbon dioxide. This leads to erosion of buildings and monuments. Particulate matter are solid or liquid matter that is suspended in the air. To remain in the air, the particles must be less than 0.1 millimeters wide and can be as small as 0.00005 millimeters. Particulate matter can be divided into two types, the coarse particles and the fine particles. Coarse particles such as road dust, sea spray, and construction are very large particles. For the fine particles that can come from the burning of the fossil fuels in the power plants and automobiles. Particulate matter can enter the lungs, can cause asthma attacks, they can cause respiratory problems, and premature death. We also have two types based on their size. We have PM10, which has a size of 10 micrometers, and PM2.5, which has a size of 2.5 micrometers. The PM10 particles have an average diameter of 10 micrometers and the length on the order of 4 times 10 raised to the negative 4 inches or 1/5 of the width of the human hair. PM2.5 is a subset of PM10 particles and include particles with an average diameter of 2.5 micrometers or less. Particulate matter can cause respiratory diseases, heart problems, and premature death. To reduce exposure, avoid polluted environments, use masks, and improve indoor air quality. Both PM10 and PM2.5 are too tiny to see and can go deep into the lungs and can cause irritation. They can also go into the bloodstream and can cause heart disease. Symptoms include shortness of breath, irritation of the eyes, tightness of the chest, reduced lung function, severe respiratory diseases, irritation of the eyes, nose and throat, and irregular heartbeat. So who are at great risk of particulate matter? They could include children, senior citizens, and people with heart and lung diseases. To reduce exposure to particulate matter, avoid being outside when the air pollution is high, do not burn wood or trash, avoid smoking indoors or outdoors, use mask when you're going outdoors, and use an air purifier. The next major pollutant is lead, which is a blue-gray metal that is very toxic and found in a number of forms and locations. They can be found from cars, in areas where leaded gasoline is used, or from power plants and other industrial sources. Lead can also be found from the lead paint or peeling paint and lead in the old pipes and drinking water. High amounts of lead can be dangerous for small children because they can cause lower IQ and kidney problems, and in adults, lead can increase the chances of heart attack and stroke. The next one is the toxic air pollutants, which can include arsenic, asbestos, benzene, and dioxin. Many toxic air pollutants come from a slightly different source, but many are created in chemical plants or are emitted when fossil fuels are burned. Asbestos and formaldehyde can be found in building materials and can lead to indoor air problems. Toxic air pollutants can also enter food and water supply, and some of them can cause cancer. Some toxic air pollutants can even cause birth defects, and they are considered teratogenic. Some of them can cause skin and eye irritation and breathing problems. According to WHO, asbestos can cause mesothelioma, which is a rare cancer of the lung, as well as lung, laryngeal, and ovarian cancer. The material can also cause asbestosis or fibrosis of the lungs, which is a scarring or thickening of the lung lining, both of which causes shortness of breath. Asbestos was used for wall insulation, mixed with plastics, sealed into floors, and built into cars. Asbestos is also resistant to heat and corrosion. The next type of toxic air pollutant is your dioxin, which is a group of chemically related compounds that are considered as persistent organic pollutants. Dioxins and POPs can be found throughout the world in the environment, and they accumulate in the food chain, mainly in the fatty tissues of the animals. More than 90% of human exposure is through food, mainly through meat and dairy products, and as well as fish and shellfish. Dioxins are highly toxic and can cause reproductive and developmental problems. They can damage the immune system, and they can interfere with hormones and may cause cancer. Dioxins can be found in the burning of municipal or hospital waste. They can also be produced in the backyard burning and automobile emissions that contributes to the release of low levels of dioxin into the environment. Dioxin being released can be built up in the sediments, and fish can build up dioxin in their fat tissues. Eating fish from contaminated water can lead to dioxin exposure in people. We also have your stratospheric ozone depleters. These are chemicals that can destroy ozone in the atmosphere. These chemicals include chlorofluorocarbons, hydrofluorocarbons, and other compounds containing chlorine or bromine. CFCs are used in air conditioners and refrigerators as coolants, aerosol cans, and fire extinguishers. Other ozone depleters are used as solvents in the industry. We also have your volatile organic compounds, which are emitted as gases from certain solids or liquids. Concentrations of many volatile organic compounds are consistently higher indoors than outdoors. Major sources of volatile organic compounds are paints, paint strippers, and other solvents, wood preservatives, aerosol sprays, cleansers and disinfectants, moth repellents and air fresheners, stored fuel and automotive products, hobby supplies, dry clean clothing, pesticides, building materials and furnishings, office equipment such as copiers and printers, correction fluid, and carbonless copy paper. They can also include graphics and craft materials, including glues and adhesives, permanent markers, and photographic solutions. In terms of health effects, volatile organic compounds can irritate the eyes, the nose, and the throat. They can cause headaches, loss of coordination, and nausea. They can damage the kidneys, liver, and central nervous system. And some organics may cause cancer in animals. Some are suspected or known to cause cancer in humans. We also have major air pollutants of biological origin. The first one in pollen. Pollen from trees, weeds, and grass can cause allergies and hay fever. Pollen pollution is expected to increase with global warming as the growing seasons lengthen. Another pollutant of biological origin is mold, and molds are problems affecting indoor air quality. Some molds produce toxins that bring on allergies and asthma. Molds occur in damp buildings or those with high humidity.